in a session. So with me today is Julie Robinson. She's a marketing manager for controllers with Rockwell Automation. She is remote. I guess, Julie, is it Cleveland you're out of?
Yes, I'm in Cleveland, Ohio.
Cleveland, okay. Yep. So yep. We have a mixed audience of here in our office live, and then we have a web audience as well joining us. So we appreciate all of our attendees. So we're going to start with kind of our usual intro stuff here and kind of what's coming up next. In May, our users group seminars go every month, and usually it's around the middle of the month, the Wednesday, middle of the month. So our next topic will be on May 17th around power quality and energy management. June is going to be migrating to the Connected Enterprise. So June is kind of a tie-in with the PLC 5 officially going obsolete, and then some of the messaging around, you have the old stuff, and what's the old stuff, and kind of what's the future hold, and how we kind of help you get to that Connected Enterprise, which kind of ties into what we're going to talk about today. And then in July, we've just added, are you in control of your industrial control system? Kind of coined that term there, but a unique new product by a company called Indigy that will be kind of launching out to the world here in July. So also, it's almost Tech Ed time. So June, the registration actually just opened up in the last day or two. I've noticed the emails. So Tech Ed is in Orlando this year, June 11th through the 16th. Definitely invite you guys to attend that. Also, looking down the road a bit in November, I know it seems like a far ways away, but the Automation Fair is in Houston this year, and first 2 days of that week is PSUG, or the Process Solutions Users Group, and then the Wednesday and Thursday is the actual Automation Fair itself. And of course, we keep our archives of all of our topics, previous users groups. Today's topics, topic will be posted to our automation blog as well. So trcnew.com for you can go back and see all of our previous events. All right. So today, we pitched this and presented this as kind of rugged computing at the edge, and then launching the new CompactLogix 5480 controller. So we thought we'd take a few minutes here at the beginning to talk about, I guess, kind of the Internet of Things, kind of edge, fog, cloud computing, and then I'll turn it over to Julie to help launch and explain what the 5480 CompactLogix is all about. So first off, Internet of Things, right? So we can all do our collective eye roll, for hearing this term again for the millionth time. But what is it? So this was kind of one of the easiest and best definitions I've seen, or simplistic definitions I've seen of the Internet of Things. And basically, it's linking the objects to the Internet, enabling data and insights never available before, right? So traditionally, Internet of Things is kind of applied to, I guess, what you might think more of our consumer type of stuff, right? So, like everybody thinks of the Nest, the smart thermostat, or my, connected toaster type of stuff, right? So some things are kind of, hokey, and some of the things are actually pretty legitimate uses for the Internet. Most of us wear some kind of fitness tracker nowadays, so that is a connected thing, right? So my data from me goes up to the cloud, and I can analyze and look at the performance of what I'm doing daily. So the industrial Internet of Things, or IIoT, is basically taking those concepts of the IoT and applying it to manufacturing or into our industrial environment. So I think it is required by some international IoT consortium that you must show this slide always. And the idea of this is basically to show you that every year the expectation is it's just going to get bigger and bigger and bigger. So so by the year 2020, which is not too far off, 50 billion connected devices on the Internet. So what's kind of enabling the IoT, especially in the industrial environment? A couple interesting things. How much data is being generated? So it's estimated that a typical offshore platform might generate 500 gigabytes of data per week. Whereas on the order of an aircraft engine is an amazing 10 terabytes of data per every half hour of flight. Just hundreds of sensors on an aircraft engine. Aircraft engines, again, not necessarily what we do day in and day out, but our turbines, turbines and turbine control, lots of sensors on board there. So a couple years ago, I did an IoT talk for the IEEE, and there was an interesting thing we showed there, and so I've kind of updated that a bit, kind of on the latest. And there's an estimated total cloud storage out there of 500 exabytes, which an exabyte is basically 5 billion gigabytes, 10 to the 18th power, or 1,000 to the 6th. A staggering amount of cloud storage available, and that number is probably about 3 or so years old. So anyway, the enablers here is that cloud storage has just become so prevalent. There's tons of it out there. It's just kind of a natural progression now that we have all this data. It's going to start to move up, into the cloud and be analyzed. Another one that we did, a couple years ago for IEEE IoT was this, and I've always loved this comparison. Is another enabler is computing power. So in 1985, the Cray 2 was it, right? It was the top of the line computer with a whopping 1.5 gigaflops of computing power. In 2011, the iPad 2 had the exact same capability as the Cray 2 as far as gigaflops computing power. So the idea here is that computing power, obviously, as we all know, has gotten cheaper and cheaper and more powerful, and we can take advantage of that capability, down into the industrial plant floor environment. So the Internet of Things, there's actually a reference model out there, and I thought this was kind of good to show. If you've seen any of the networking Purdue models, is a pretty similar approach in how they kind of reference the IoT world. And the wording on the right is actually pretty good way to think about that, right? It's devices send and receive data interacting with the network, where the data is transmitted, normalized, and filtered using edge computing before landing in data storage or databases accessible by applications, which process it and provide it to people who will act and collaborate. So essentially, you see the layered approach, edge device being all the way down at the plant floor, sensor, device, or machine, some kind of intelligent edge node, up through the layers of networking into the enterprise, up into the cloud. So looking at that kind of data flow in that stack, right? So typically, you'll see here is that control and policy type of stuff would come down from the cloud down to the edge, and data, of course, could flow in either direction, up to the cloud and back down to the plant floor. And of course, security is wrapped all around all those different layers. And one more kind of way to kind of look at that or think about that is, we've gone through the IT and OT convergence discussions over the last several years with all the prevalence of Ethernet networking on the plant floor, and kind of see where that reference model kind of balances out. So IT is above the gray area and OT on the bottom side. And you can kind of see there are some differences in how IT and OT tend to think and operate, right? So on the IT side, you're thinking your larger enterprise type stuff. I mean, it's very, it's more query-based. Data is typically at rest, and it's in a non-real-time format usually, or non-real-time analysis. Whereas on the OT side, it's event-driven. Data is always in motion between nodes or devices, and it's real-time data. So wanted to just take a minute to kind of discuss the concepts of cloud, fog, and edge computing. So when the fog computing concept has kind of come into the discussion over the last couple years with the IoT model, and of course edge device. So I think everybody pretty much understands the cloud concept, right? Basically, some kind of remote server of some sort that's going to receive and aggregate data, and it could be from fog nodes, or it could be from edge nodes directly up into the cloud. With the cloud, you have the ability to perform deep analysis on that data to gain your business insights to help you run more productively or optimize your performance. And of course, you can create rules and send those down to the down to the fog nodes and edges. So that's kind of that data flow we saw earlier, where policies and control can go down. So a fog node might be kind of a new concept, perhaps. It's not really new as far as what we've. I don't think it's really new as far as how we actually do things in the industrial world. But the idea of the fog is that it's a low to the ground computer cloud, shall we say, right? Fog is close to the ground, so bringing that computing capability closer down to the ground level or to the end user level. So the idea here is that to try to shove, as just like the aircraft engine was an example, right? 10 terabytes of data in 30 minutes. So if you have a plant floor and all of these, the plant floor has all these sensors and they're trying to send all this data up to the cloud, that's going to become, huge challenges based on just latency of getting the data up to the cloud, bandwidth issues. Let's face it, a lot of our industrial, in this area especially, we don't necessarily have internet connection, right? At some places, think of an offshore platform, not always, easy way to get connected with. So, so the idea is that instead of trying to go straight up to the cloud, the fog node is kind of that intermediate level where you can bring that device data into the fog level. It could perhaps perform some analytics or some pre-analytics on it. It could also probably filter out some of that data, because not all that data that's coming from the plant floor is needed to go up to the cloud either, right? So you can kind of do some filtering on that, figure out what's really important, pass it on, and then periodically send that data up to the cloud when you have good connections, or kind of optimize that data send up. And edge computing and fog nodes are actually probably pretty close to each other. The idea is that now on the edge, is you're bringing that computer even further down to the user level. So fog node might have been in our kind of examples, might be like a factory talk historian or a factory talk view type of kind of layer. Now you're bringing the edge is probably bringing it down to even closer down to the actual user on the plant floor. So again, the advantage there is a very low latency. Data is coming right there from the equipment to the edge device. It does reduce that bandwidth of having to send a lot of data throughout, and could also be considered as probably a bit of a more secure approach, because that device is further closer down to the end user itself and not sitting up at some other layers that could be maybe more easily attacked. So on the so just real quick, this was when we talk about the 5480, we're going to show that it's using Windows IoT, Windows 10 IoT on it, and there are some IoT operating system options out there. Windows IoT is one of them. Mobile, core, and enterprise. Just wanted to kind of introduce that to you guys before Julie talks, is because the enterprise is really Windows 10 embedded is what it is. So it's the full capability of Windows 10, but in an embedded version. Of course, Android, WinRiver, VxWorks. VxWorks has been around in the industrial space for quite some time as an operating system. And of course, the Linux. There's a core, Ubuntu core as well. But I think the natural selection for us is the Windows 10 IoT, because that gives us the ability to run already established Windows software on board there, right? And there's no need for any additional custom development. So this naturally brings us to where this is all going, and that is analytics. So this graph, this slide looks very similar to that model we just saw a few minutes ago. So devices on the plant floor, right? So that's your intelligent devices, your smart machines, sending data up to the system, which is kind of that, perhaps that fog layer there, where you're going to start to do some analysis, some real-time optimization of the machines, some predictive maintenance capability, and looking for any kind of abnormal type of system behavior. And of course, ultimately, that data we could send up to the enterprise or up in the cloud for business intelligence. You can see some of the reasons there: site-to-site benchmarking, and just better insight into your operations. So how that kind of looks, this is a bit of a future look for perhaps for Rockwell and for where we see this going, and that's what's going to be kind of considered as FactoryTalk Analytics and analytics for machines. So the approach here is very similar, where we'll have some edge devices or just sensors and devices on the plant floor. There'll be some kind of gateway to kind of take that information up, and there will be a cloud, be it either kind of a larger cloud external or a fog kind of cloud node, perhaps local to the facility, and you'll be able to kind of bring that data up, analyze it real time, dashboards, storage dashboards, real time intelligence on your machines or your operation. So this slide just kind of shows maybe some of the new type of complexities that might come into the analytics around IoT. So traditionally, you're capturing data, you're storing it, you're analyzing it. With the IoT now, again, you have lots of data coming kind of from the devices. So the idea is to kind of try to reduce that data at the edge, try to use that computing power, use that capability, at the local level to try to take some of that heavy lifting, crunching of stuff, filtering out the data, and then passing it along for longer term storage and for deeper analytics. All right, so just to kind of round out this part of it is just a little quick snapshot of a couple portfolios here. Software and analytics portfolio. So Studio 5000 is our tool for developing control logics, compact logics, as well as to do some troubleshooting and insight into the equipment. FactoryTalk View and Team One. Team One's kind of a new development, kind of team communications mobile app platform that allows you to connect with your equipment as well as connect with your team, your actual employees on the plant floor. And then of course the last column is kind of the new guy on the block, and that's the FactoryTalk Analytics again, which will be coming soon, and that will help you to aggregate all that data, make some analysis on it real time, and again kind of gives you some dashboarding and insights into your equipment. And the whole idea of that is to help you be more productive and hopefully maybe catch some issues before they become real shutdowns for you. And last slide for me is just a operator interface portfolio overview. And I want to do this before we gave to Julie, just because I think everybody knows panel view pretty well, and everybody knows we have the panel view on the operator interface product line. But Rockwell does have a line of industrial computers, Windows, all-in-one touchscreen type industrial computers for the plant floor for hazardous location, as well as just panel mount in a non-hazardous location, and then and launching here very soon is the new VersaView line, VersaView 5000 portfolio, which will include thin client nodes. So an all-in-one thin client, as well as just a node box thin client, and of course the thin clients will be ACP Thin Manager enabled. I should just say Thin Manager enabled now, no longer ACP. And so just to make you aware that there are other industrial computer products from Rockwell. But with that, we'll turn it over to Julie. I'm going to make you, Julie, I'm going to quickly switch you over to presenter. And we'll let Julie introduce herself and the new CompactLogix 5480 controller.
All right. Thanks, Wayne. So let me know, Kate, when you can see my screen.
Yep, you're good.
You see it? Okay, great. All right, so hi everyone. My name is Julie Robinson. I am marketing manager for our controller business. I am up in Cleveland, Ohio. So actually, we have some glimpses of spring here. So it's starting to get a little warmer up here, and the grass is getting green. So it's beautiful Cleveland, Ohio. So I'm going to talk to you today about the CompactLogix 5480. So this controller is going to be launching in the next couple months. It'll be launching this summer. And we'll kind of talk through how it fits into the portfolio and where we think this might be a good fit for some applications that you might have. So just to kind of level set us and take a look at what we've got today. So if we look at our Logix controller portfolio today, we have what I'm calling our general purpose controllers. So we have the CompactLogix 5370 and then the ControlLogix 5570. So these have been around. They've been around for a little while. These are kind of our go-to controller for many of the applications. They can meet the needs of many of our applications. But there is a subset of applications that are starting to need kind of that next level of performance. And so starting in 2015, we launched the ControlLogix 5580. So this is what we're calling our high performance controller. And then in 2016, we launched the 5380. So this is a CompactLogix version of the 5580 controller. So unlike in the past, in the past when we introduced a new controller, for example, when we introduced the L7, we raised the price on the L6 and we sent it into end of life, what we call end of life status, and we tried to get you to quit buying it, right? So we're doing things differently this time around, because we do recognize that again, the 5570 and the 5370 still are still more than enough to meet a lot of applications that are out there. So you'll see these two lines, or like these two paths, will continue in parallel. You can still purchase the 5370 or the 5570 if that's what your application requirements kind of lead you to, or if you need that next level of performance, you can always go with the 5380 and the 5580. Then you'll see I now have another line here. I have kind of a third grouping, and this is where the 5480 is going to fit in. And so this is what we're calling our high performance open controller. So basically, I took my 5380 controller from right here, the CompactLogix. I put it on an Intel chip, and then now I'm allowing Windows to run alongside of it. And that's what the 5480 is. So again, it meets a different need in the industry. So there are certain applications that are asking for this, but it is in no way going to replace any of our other controller lines that are out there today. So again, just these three paths will continue in parallel with just more options for your controller, for your control system. So again, the big thing here with the 5480 is it is a Logix controller. So first and foremost, it is a Logix controller, just like all of our other ControlLogix controllers. All your real-time control is done in Logix. But now we have the ability to run Windows alongside of Logix. And so I can install third-party applications on Windows and run that right alongside of Logix. It does run on a commercially available CPU. So this is our first Logix controller that does run on an Intel chip. So that is a change. In the past, all of our other CompactLogix and ControlLogix controllers, those are on our own ASIC. So we can manage the life cycle of those ASICs a lot more closely. So this will have a different life cycle. It won't have that same very long life that we know and love with the ControlLogix and CompactLogix that we have today. But for a lot of our customers, they are more interested in the flexibility and the performance that you can get by running this on an Intel chip. So again, just like our existing 5380 and 5580 controllers with all of the security features that are available, those are available on this. We have the SD card that is available for storage of the Logix user program. We do have the USB port just like on our existing Logix controllers. And then we do have some more additional gigabit Ethernet ports, and I'll go through those in a second. And we do have an embedded monitor interface, so you can hook up an industrial monitor right into the controller to run, for, as an example, maybe you want to run an embedded or an integrated visualization system. So you have your HMI application, you've got your FactoryTalk View application running on Windows, you hook up your monitor, and then you have it all integrated in a single piece of hardware. So a couple of the applications where we think this is going to be a good fit, and I will say these are just kind of a sampling of the ideas that, as we've been talking to customers and as we've been kind of thinking through how customers are going to use this. This is a small subset of ideas. I think every time I meet with a customer, I learn something new for how they kind of envision being able to use this, having that Windows integration, right inside the controller. But at a high level, so some things that we're looking at, it will support up to 150 axes of motion. So for very large motion applications, this will be a good fit. So right now, the largest 5380 controller supports up to 32 axes. And then once you go into Control Logix, if you're on the 5580 platform, you can get up to 256. So again, this is kind of a good, this will fit nicely right in the middle where you can hit those larger applications. Again, at a high level, third-party applications without a PC on the plant floor, a lot of customers that we talk to are really trying to simplify their architecture and really kind of shrink down their systems. And so anywhere where they can consolidate and maybe, eliminate a PC on the plant floor, they are very excited about. And so we think this is going to provide a really nice opportunity to potentially do that. And one of the examples is integrated visualization and control. So again, with that integrated display port, you can hook your monitor right up to it, and you can run your visualization system right off of the controller. Another example is a thin client. So we're running some tests right now to run Thin Manager on this and see if there's any kind of see what the boundaries are around that. Another really popular example is data logging. We talked a lot about data and analytics, and so being able to analyze that data right there, right at the point of your device or right at the point of your machine, provides a lot of value. And then line controller, or like a data concentrator. One of the common things that we've heard from a lot of our customers is that they want a controller that can manage a lot of data. And so with all those gigabit Ethernet ports that we'll look at here in a second, it'll really allow you to funnel a lot of that data up into the controller. So you might have you might have one 5480 in your plant that is aggregating data from a bunch of other Control Logix or Compact Logix controllers that are actually doing the line doing the machine control. Right, so you've got your PLCs that are doing machine control, and then now 5480 kind of sits on top and can aggregate all the information out of all of those individual machines. And then finally, integrated machine vision and control. So again, just trying to find ways that you can eliminate that PC on the plant floor and consolidate that into in your system. So we think that's another option for, at least for small vision systems. It's a good opportunity, or a good potential opportunity. And then on this slide, I wanted to again just kind of show that there really are a lot of different possibilities for what you can do having that Windows core running in parallel. So in this example, of course, we're showcasing a lot of the Rockwell products. So I'm showing FactoryTalk Viewpoint, VUME, SU Station. This is our Thin Manager acquisition. So, and then a lot of our partner products as well. So you can just kind of see that there really are a lot of possibilities for how you can use this and leverage having Windows right there running alongside of Logix. So then if we look at the controller a little more closely, I mentioned a couple times there are multiple gigabit Ethernet ports. So so A1 and A2, which are these two bottom ports here, are very similar to how 5380 works. So where you have configurable device level ring or dual IP. So you could actually have two separate IP addresses assigned to these two ports, or you could set it up for device level ring. And then there's actually a third gigabit Ethernet port that you can hang devices off of it if you choose to, or you could configure it as like an upstream port. But it is still another SIP-based port. And so these three ports on the side here are what we call the Logix ports. So this is where you would hang your I/O, your devices, any of the Logix real-time control would be hanging off of the side. And then on the bottom, there's an OS dedicated port. So there's another gigabit Ethernet port on the bottom that is dedicated to Windows. And so think of this as the NIC card on your laptop, right? So another just Ethernet port that is available to Windows. There are two USB 3.0 ports on the bottom, again, dedicated to Windows. These could be used for hooking up a keyboard and mouse. If you wanted to hook up an external hard drive, something like that, you could use those for. And then, of course, there's the display port where you can hook up a monitor interface. And then we talked about the USB device port, so programming port, right? So you can hook right up into Logix. And then here's where the SD card door is. It is DIN rail mounted, and then local I/O is going to be 5069 I/O. So this is our next generation compact I/O that was launched at the same time as the 5580. So it was launched in November of 2015. So that's going to give you the highest performance I/O. You certainly don't have to use that. You can certainly use any of our existing I/O platforms that are available today. But if you're really looking for that kind of next level of performance and those really fast screw-to-screw times, then 5069 local I/O is going to give you that performance. This does have fans. It does, I mentioned it runs on an Intel chip, so it does run on an Intel i7 2.4 gigahertz chip. So it runs hot. It does run hot. This is the first controller of ours that has fans, so this is a little bit different. It doesn't need to have two fans, but we didn't want to have a single point of failure. So if one fan fails, then the other fan can pick up and has, it can cool the controller with a single fan. And then at that point, you'd be able to swap out the fans. You can swap them out during runtime, and we do encourage you to go ahead and swap them both out at the same time. Another kind of key difference, you can see where we've got the certs listed over here in the bottom right. Another key difference between this and the Control Logix is it will not have hazardous location or marine certifications. So again, just kind of a key difference to be aware of if you're looking at this for possible applications. And then this just gives a little bit closer look at the Ethernet ports. So again, you've got the A1 and the A2 ports. These are the two ports that can be configured for dual IP or device level ring. And then you have the B1 port that is another SIP-based port, but it can also be configured as an uplink. So you can see here domain name, primary and secondary DNS attributes. And then X1 is the port on the bottom, and that's going to be the Windows port. So the important thing there is that there is no bridging of I/O, right? Any of your I/O, any of your devices are all going to be connected to one of these ports on the side here. So then if we look at a little bit more at the specifications on what's under the hood, so we talked, again, it is a real-time Logix controller. Windows does not impact, so if Windows blue screens, if Windows shuts down, your real-time Logix will still keep on going, so it will not impact your runtime. It does run Windows 10 IoT Enterprise, and so what that means is it's not going to try to phone home for updates, so updates will be turned off by default. You can certainly turn them on if you choose to, but they will be turned off by default. It does have we talked about the integrated display port so that you can hook up an HMI to it. In the future, so we will have a future release that will support high-level languages. So, so again, in the future, what you'll be able to do is you can write like a C# application or a C++ application, and we'll have the ability to invoke that external routine. So from within Logix, we'll have an instruction available that you can invoke an external routine. So you basically would jump out of Logix. You can execute your C# or your C++ program that's running in Windows, and then kind of jump back into to Logix. So again, that's a future capability. On the initial release, you'll have an embedded links. I call it an embedded links pipe. So basically, anything that you can do in RS Links Enterprise today, you'll be able to do in the controller, and you'll have that kind of embedded pipe available. So if you install RS Links Enterprise on Windows, when you open that up, you'll put in a virtual backplane driver, and then you'll see the 5480 pop right up, and then you'll have access to the 5480 through that, right? So you'll be able to browse tags, you'll be able to do anything that you can do through Links. And then we talked, it is an Intel i7 2.4 gigahertz quad-core processor, so it is a really powerful CPU. It is a very fast CPU. 32 gig of eMMC hard drive space. So it's 32 gig before we put Windows on, and then after Windows is installed, it's roughly 16 to 18 gig free space. So that gives you 16 to 18 gig to install your applications and have some local storage on the controller. As far as RAM, it's 5.75 gig of RAM. It does have the three Logix gigabit Ethernet ports and the one operating system port. We've got the monitor interface, USB ports, and then operating temperature. This is consistent with our Logix controllers, so it is 0 to 6 dC. All right, so if we look at kind of what's the future look like, and what's the initial release going to look like. So again, the initial release is this year. It's coming up very, very soon, right around the corner. Probably in the late June timeframe is what we're looking at right now. It will have the configurable device level ring or dual IP on the Ethernet ports. It will have Windows 10 IoT Enterprise, and then it will have this internal SIP communication between Logix and Windows. And then it will also have we're calling it FactoryTalk View software compatibility. So one of the key use cases is being able to run your visualization, so run your HMI software off of Windows, and so you will be able to do that on this initial release. At Automation Fair, we did have the 5480 on display, and we showed it running one of our, we call it the cookie demo. It's like our connected enterprise visualization demo. And so we had the HMI application running on Windows, and we also had Logix Designer running on Windows. And it didn't skip a beat, right? Like it ran that very well. So it definitely can be done. And then if we look at a future release, again, this ability to do an external routine call. So this is where you can invoke an external routine and execute a high-level language program that runs on Windows. So that's where you get your C# or your C++ program. Another capability that we'll have in the future is Windows event support. So what this will do is it'll be able to monitor Windows events, and then you can trigger things in Logix to happen based on those Windows events. Windows NVS Store support. So in the initial release, you'll be able to back up your Logix program to the SD card, but you won't be able to back up Windows just yet. And so this capability will allow you to back up the entire controller to your SD card. One thing I didn't mention for the operating system, the way you'll be able to use Control Flash to mount the image onto Windows, your Windows image. So it'll be just like when you flash your firmware, right? So you put your Logix firmware on there using Control Flash, and then you would do the same thing for your Windows image. Another thing that we're looking at in our next release is OPC UA data access support. So being able to access devices that are running on OPC UA. And then finally would be Panel V5000 terminal support. So right now at the initial release, you will not be able to hook up a Panel V5000 to it, but we are looking to have that capability in the next release. And then these are some more, we talked at the beginning about some possible use cases. Again, as we've been talking about this controller and meeting with customers and trying to understand what problems they're trying to solve, I've been just kind of collecting a running list of different use cases, and so we've kind of so we've consolidated those use cases and we've kind of grouped them based on again what our customers are trying to accomplish. And so so these are just some other ideas. We talked about some high level things at the beginning, but some other high level ideas are running our manufacturing intelligence software, so things like FactoryTalk, Vantage Point, running that on Windows on this controller. We talked about Logix Designer, our visualization software, and again data loggers. A couple other things that have come up quite a bit is being able to run complex algorithms on Windows. So things that are just very intensive with computations that you wouldn't necessarily do in the controller that you would want to do on a PC, for example. Now you can do that in this controller right alongside of Logix. Maybe even some model predictive control, right? There may be even some opportunities for some NPC type calculations. FactoryTalk Analytics, of course, that is definitely a very popular use case and where we think we can get a lot of value. Initially, the FactoryTalk Analytics is going to be available on one of the industrial PCs, so one of the VersaView PCs. But we are looking at ways to be able to license that software to allow it to run on the 5480. And then same way with Cloud Gateway, right? There's a very clear opportunity with the 5480 to kind of act as a cloud gateway. In particular in cases where maybe you're using it as a line controller, kind of a data aggregation, or as a method for data aggregation. And then again, of course, run Logix and HMI in a single piece of hardware, kind of eliminating the PC on the plant floor. So those are some ideas. Those are some examples as we've been talking to folks and where we think are key areas that this would be a really good fit for. So certainly, if you guys have some thoughts for where you think you can use it, feel free to pass those on to Wayne, and we can kind of keep populating the list, right? Our other intention is to take some of the key use cases and start developing white papers, so that when the 5480 does launch, we'll have very detailed application use case examples with white papers on how to set that up. If this is what you're trying to accomplish, what's the best way to set this up, and if there's any boundaries or anything like that we've discovered throughout all of our testing that we can pass along to you, we want to make sure that we have that information available. So that's kind of the other part of collecting these use cases for the future. So that's the last of my slides. I talked a lot. I went fast. I don't know, Wayne, if there's questions in the room. If you wanna talk through anything.
Yep, we'll open it up to questions. If you are on the web, you can enter into the chat. There might be a way to unmute the phone line there too on your end, but the chat would work great. And any questions in the room, we'll give it a minute to. People, they're stunned over here by the product. They're stunned silence. But we might actually have a question. Hold on.
What type of port did you have for the monitor?
So it's a display port. So it's a let me go back to it. Let me show you. It's called DisplayPort, and so if you have like an HDMI or a VGA, what you do is you'd use like one of the pigtail cables, and you'd be able to hook it up that way. So DisplayPort is like a kind of a universal. It's becoming more of a universal standard. So we think a lot of monitors are actually going to that in the future. In fact, our new Versity monitors are going to have DisplayPort. But as monitors kind of catch up, you might have to do the pigtail to the HDMI or the VGA display.
Having this on our screen locally off of a Surface tablet, which has that DisplayPort little adapter on it. So Macs have it as well.
Oh, perfect. Yep.
All right. The mini DisplayPort. I don't know. Is there an even smaller version of it? A mini display versus DisplayPort.
A smaller display.
So this one's.
Yeah, I'm not. Yeah. Okay. Yeah, so display. Yeah, I know there's 1,000 different cable interfaces out there. I'm even hearing there's a USB-C coming out at some point soon. So yes, lots. Got to always keep up with these cable connectors. Checking online, I don't see any questions from the web audience. So we'll. Oh, hold on.
So in addition to the jump external subroutine, you mentioned you're going to have Lynx Enterprise running on it. So do you have like the API that you could pass through Lynx Enterprise to get to the controller?
So what it is you'll actually have to install Lynx Enterprise on the controller, right? We can't actually ship it with it installed on there. But what's built in is kind of the built-in communications pipe between Logix and Windows. And so once you install Lynx Enterprise on Windows, you'll be able to communicate just like you would if you were running it on a PC, right? Like it'd be the same workflow, same user experience. The only difference is that you'll add a virtual backplane driver, and then it'll pop up. So it's not like you got to type in. You don't have to map your IP address and all that to be able to browse to be able to see the controller.
Okay, thanks.
Does that make sense?
Yeah, it does. Yep, it does. So
okay.
yeah, it just works just like it works today. It's just now the path is through a virtual backplane driver.
Yep, exactly.
Okay.
From online, Julie, as well, around the hard drive storage. Anyway, will it be expandable at some point in the future, or external hard drive capability through there's a USB, or expanding hard drive capability.
Yeah, so so as of today, or as of the initial release, it will not be expandable, and it's not. So here's where it kind of gets. We talk about it like it is a PC, but then here's where it's different from a PC. You can't just pull the hard drive out and swap it out. You can certainly use one of the USB ports for additional hard drive space with an external hard drive. We are looking at modules that we can mount on the rail, right? That would give you additional hard drive space, but those are a little bit further out, right? There's going to be a little further out.
Good idea. Okay. I don't think I see any other questions in here, so we'll give everybody a chance to kind of a last call for questions. Oh, I see maybe something coming in. Okay, Studio 5000 be installed on the PC side and used for programming in the same PLC? I would say yes.
Yep, and it'll so I don't think I mentioned this, but it will be supported in V30. So V30 released in December of 2016. And so if you do have V30 and you look in the, try to add your hardware, you will see a 5480 in there. And the reason we did that is since we're moving to one release per year, so we're moving to just having one Studio 5000 release per year, we didn't want to have to wait for the, we didn't want the hardware to be out and then not have software support. So we went ahead and put it in there early, a little bit early. And then that way, as soon as the hardware is available and does begin shipping, then you can use it you can start using with V30. but yeah, we had Logix Designer running on it at Automation Fair, and it ran fine. There was plenty of hard drive space. You know, the kind of the system requirements. We have plenty of RAM. It ran very well. So.
That's a good question. Yep, I think once this, like you were saying too, Julie, once this comes out, I think the ideas will start to flow. It's going to be kind of interesting to see what people will come up with, you know, to do on this. I like the idea of the web server. I saw that on there as one of the concepts, use case out there too. So that's a interesting idea.
Yeah. Yep.
So.
Yeah, I think there's a lot of possibilities. I think it'll really open up the doors for a lot of things that even we haven't thought of. So it'll be fun to see how people use it.
Yep. Okay. We got another question. Can RT vision systems, or I guess real-time vision systems, be implemented on the PC side? So. And.
Yeah, I mean. So, so it's a little harder for us to test that kind of thing, right? Because we don't actually, since we don't own any vision systems, we don't have Rockwell products that support that. So it's a little tough for us to test it. And so what we've been telling folks is just, check out, we've got the specifications on the processor, right, on what the Intel chip is capable of, and so take a look at the requirements of the vision system and try it out, right? Like you can always try it out and see how it goes, right? Like see how it. Now there are going to be, I do kind of caution you for some of the larger systems, right? Depending on how many cameras you've got, it might be a little bit difficult just because there's only 2 USB ports on there. So you'll just have to kind of take a look at the requirements and see if it's a good fit or not.
So I got another question on about connection terminals located on the processor itself for. Well, what are the connection terminals located on the processor itself for? So I guess go back over those Windows side connectors on the bottom there.
I assume you're talking about these guys, right? Yeah,
oh, okay.
Right?
Yep. Power, I would.
Yeah, so just like the 50, so you will notice there are 3, there are 3 on this one as opposed to, like if you look at the 5380, then you only have 2 of the terminal blocks. So this one will support connection to a UPS. That is another difference with this. So you can hook this up to an uninterruptible power supply. One of the things so because it is an Intel chip, it doesn't have the same energy storage module as we have in ControlLogix controllers today, and CompactLogix controllers today. And so, because if you did, for this controller, the energy storage module would be enormous, right? Like it'd probably be bigger than the controller. And so we had to figure out a more creative way to kind of meet that same need, right? And so you can hook this up to UPS. And then that way it will, if there is a power cycle, it will basically serve the same function that the energy storage module served, right? Where it'll hold the program, it'll hold it through a power cycle. So that's what that extra connection is there on the front of there. And then the other one is for module power and then the I/O power.
In the room here, we actually have a 5380 on the wall back there, so we can show you what those terminals look like. But that question came from online, so we'll have to.
Oh, okay.
But all right, let me see. Any other questions? We might have set a record for questions today, so that's good. No, it's great. We'll give everybody just one more minute to get those fingers typing. While we wait for that, we'll thank Julie again for taking the time to join us. It's always great when we get a factory representative to present for us, because we definitely get a much better insight than us trying to do it. So we really thank you for your time joining us today. And it looks to me like that might have been it. So we will we'll go ahead and conclude our session today. We thank everybody again for joining us. You can always follow up with myself or your account manager, Chris Watkins, who's also on the line, remote in Houston, solution architect for Rockwell. So we're always here to help you guys. We've got additional questions after. So Julie, thanks again, and enjoy the rest of your day.
All right, you too. Thank you. Thanks, everybody.
All right.